Okay, we're looking at number 19. It's a limit, and to limit as x goes to infinity. That's not a finite number. And then it's a rational function, x squared over 3x squared plus 1, and that equals 1/3. So what are we going to do? We're going to use the epsilon n definition now. So let's go to the whiteboard and do it. All right, and we're on number 19. So let me write this down for you. Number 19. And 19. And I want to kind of remind you that that we believe the limit's easy to intuitively understand. And I'll go through what you did in Math 119 to do that. And also, when I say math, pre-calculus and also in calculus. So the teacher, what they said is divide through by the highest degree variable. And if you did that, this is not a proof, by the way. That would be 1. This would be 3 plus 1 over x squared. And then they'd ask you to think about it. And, what the top goes towards 1. And the bottom, this is just 3, so it goes towards 3. But this thing, as x gets really large, 1 over a really large number squared, it's going to go to 0, so it's 1/3. So it seems pretty reasonable. Right? Let me get my eraser out and erase this business over here. I'm just going to say it's reasonable that it's 1/3, right? But certainly we want to be able to prove it. And we're using what's called the epsilon n definition, all right? So let's write down some facts over here. We're using epsilon n. And let's write down what we need to do. We're given something. And we're starting off with the epsilon, by the way. And this is where some teachers might say, oh, let epsilon. But again, I like what black pen, red pen does. He's very consistent. Given. And I'm going to say given an epsilon greater than 0. All right? The next thing is going to be choose. Now we're on to the n part. I don't know what that is yet, but I'm going to try to figure it out. N is going to be something. And I'm not sure what it is at this point, but we'll get there. All right, so what I'm going to do now is suppose, right, S-U-P-P-O-S-E. Suppose x is greater than n. And I'm looking at this thing, as we're going towards infinity, I might as well say, that we're greater than 0 is also, that's a positive number, all right? Now, what I'm going to do now is the check part. This is the check. And I'm hoping the check leads to this n. I really do. And I'm going to write this down over here. And what do I get? Absolute value, x squared over 3x squared plus 1. That's the function, by the way, minus the limit value, 1/3, the absolute value of that. Well, I got to simplify this. And I want to point out, simplifying it, looking at it, I'm going to say 3x squared plus 1. And then you get 3x squared on top, minus, let's write this down, 3x squared plus 1, absolute value. I'm going to continue to simplify this. This is equal to, well, looking at the top, you really just get, minus 1. And the absolute value minus 1 is just 1, right? On the bottom, what do you get? You get 3 times, well, you get 3x squared plus 1. They're all positives. So I'm going to just put down 3, and then 3x squared plus 1, all right? Now, this is where the tough part comes in now. What I put down now, maybe a little more simplification over here. Not necessary, but let me see if I can do that. 9x squared plus 3. Right, now what do I know about this thing over here? I'm trying to get it's like a bound on it. And looking at it, I'm going to say 1, and then I'm going to say 9x squared in the bottom. Now I hope you realize that 9x squared plus 3, it's a positive number, by the way, is certainly going to be greater than 9x squared. All right? And if you took the reciprocals, what do you get? 1 over 9x squared plus 3 would be less than 1 over 9x squared. All right, so I'm going to say this is pretty reasonable. All right, let's move on to the next thing. I'm trying to get, x. I want to get rid of that 9, by the way. I'm looking at this over here, and I want to get rid of the 9 now. So I'm going to put 1 over x squared now. Again, I hope you realize that 9x squared is going to be greater than x squared. All right? And then what I'll do is reciprocal, they're both positive, by the way. 1 over 9x squared is going to be less than 1 over x squared. All right? So what do I got over here? I got this. Right, so now I can say that I can put the relationship down now as far as this goes now. I want to get this n in the problem now, and we'll figure out what it is in terms of epsilon in a second. And it's going to be an n now. And what's going to be, I'm going to put 1 over n squared. Let me go through that. Let me get my eraser out too. I want to get rid of some things. Get rid of this business over here. And what do I know? I know x is greater than n, greater than 0. I know they're all positive numbers, so I'm going to simply say if that's true, x squared is greater than n squared. And then we can write the reciprocals, or positives, by the way. 1 over x squared would be this. All right, so I got that relationship. I figured that out. Now what I'm going to do, I'm trying to get this n in terms of epsilon. So I just set it equal to epsilon, and then I'm going to solve for epsilon. What are you going to get? 1 over n squared is equal to epsilon. 1 over epsilon is equal to n squared. And I can figure out what n is. And again, I want to point out n is a positive number, so I'm not using plus or minus. So it's going to be 1 over the root of epsilon. I think I'm there. I'm done now. 1 over the root of epsilon. All right, QED. And again, I want to remind you, this problem set comes from Black Pen, Red Pen's YouTube video series on these rigorous limits, by the way. And I'm going to say what he doesn't put QED down. He puts a square box down, shades it in, and calls it a day. It's really the same meaning, by the way. Thank you.